In this question, a scientist wants to determine how many moles of lithium, Li, are made in a reaction that produces 2.98 liters of nitrogen gas, N2, at STP, that's standard temperature and pressure. Okay, so our first step is going to be balancing our equation. So let's draw a little table to show what we have before and after. So we have lithium and we have nitrogen. So in the reactants, I have 3 lithium and 1 nitrogen from Li3N. And then in the products, I have 1 lithium and 2 nitrogen. So I'm going to have a go adding a 2 here so that we'll end up with 2 nitrogens in the reactants to match the 2 in the products. And I'm going to recalculate and see if that did what it needed to do to balance my equation. So now I have 2 sets of Li3. So I've got 6 lithiums in the reactants and 2 sets of N, so 2 nitrogens in the reactants. In the products, I have 1 lithium and I have 2 nitrogen. So nitrogen is now balanced, but I need more lithium in the products. Right now I have 1, but I need 6. So there's a simple fix for that. I can just add a 6 here. And now I have 6 lithiums in my products as well. So my equation is now balanced and I can fill in those answers. Remember, on this platform, we enter a 1 when there's only 1 of that thing, even though usually we just wouldn't put a 1, we'd just leave it blank there. So now looking back to our question, we're starting with 2.98 liters of nitrogen. And first step is going to be converting from liters of nitrogen to moles of nitrogen. So to do that, we're going to need our conversion factor. At STP, which we're given in the question, standard temperature and pressure, 1 mole of gas has a volume of 22.4 liters. So that's going to be our conversion factor we're using for the first step in our dimensional analysis table. So I'm going to put liters of nitrogen on the bottom because I want the liters of nitrogen to cancel out. And I want to convert into moles of nitrogen. So that's going to go on the top. And then I need to put in my numbers so that the top and the bottom equal each other. So we should have 1 mole of nitrogen, so that's going to be on the top, is equal to 22.4 liters of nitrogen. So the 22.4 is going to go on the bottom. So that's my first step, converting from liters of nitrogen gas to moles of nitrogen. Now I need to convert from moles of nitrogen to moles of lithium. So this is where I'm going to use my balanced equation to figure out the ratio between nitrogen and lithium. So let's fill in our units in our next column. We're going from moles of nitrogen, that's on the bottom so it will cancel out, into moles of lithium. And for our number, we're looking in our equation and we have 6 moles of lithium produced for every 1 mole of nitrogen produced. So what that tells us is that 6 moles of lithium are produced for 1 mole of nitrogen. So that's going to be my conversion factor that I'm going to use in my last column here. So for every 1 mole of nitrogen, we get 6 moles of lithium. Awesome. So now I'm into the unit that I'm trying to find, which is moles of lithium. So we're ready to go ahead and do our calculation. So anything on the top gets multiplied together. Anything on the bottom gets multiplied together. And we're going to divide top by bottom. Then we can cancel out units that are the same on the top and the bottom. So liters of nitrogen cancels, moles of nitrogen cancels, and we're just left with moles of lithium, which is what we're trying to find. So we end up with 2.98 multiplied by 1 multiplied by 6 moles of lithium divided by 22.4 multiplied by 1. So if we put that all into our calculator, we're going to get out 0.798 moles of lithium. So we can fill that in our answer box over here. Awesome. So you'll notice this question works exactly like all the other stoichiometry problems we've done. The only difference is we're now also using our moles to liters of gas conversion as one of our steps.